what I've done is gone into these CLEs and I've looked to see where the maths actually sits within them. I think the Penguin Project one actually has some maths links in there already, doesn't it? Not links, but it's got an outline of what that maths might actually look like. So, oh, I can use this, can't I? So this is the first one we're talking about, the foundation one, which is about Weather Watch. So these are the Australian curriculum links for mathematics for that particular unit of work. And you've got those in your package there. This is the one for sound and hearing. This is the one for the Penguin Project. You can see why I like that one, because there seems to be an awful lot of maths in it. So going through from measuring an order, telling time, to investigate the relationships with the clocks, which I'll talk to you about in a moment. The change in temperature and calculating the change in temperature, looking at the scale on thermometers, and also collecting, recording and analysing data. So this is for that particular one, it's a Year 3 Physical Sciences, and there is the Science Understanding Content Descriptor and the Achievement Standards underneath. During the learning intention basis for this one was to observe and explain that heat can transfer from one object to another, understand that scientists search for patterns in data, they make accurate observations, record and represent observations, and identify patterns from those observations. So I went out to a school to do this particular lesson with them. Basically, I'll just give you a brief outline for it. It was a bit hard to bring all the equipment from Adelaide to do this because you need all these cups and lots of other things, tin cans, which don't work very well. But you can see that the idea was the kids first of all got out there in a group and we got them to huddle together. And what's happening to you kids in the middle? Oh, we're getting warm, can we move? What about the ones on the outside? And it was a pretty cold day. And they're saying, oh, we're getting cold. Okay, so let's shuffle around now and let's see what's going on. And they shuffled around and got into the position. And there's a video on there as well that Kate had from the CLE, which actually directs you to a video of what that looks like with the actual emperor penguins doing it. So to mirror that in this investigation, what we did was we have 7 cups. And those 7 cups, it's better if you use tins, and I'll explain why in a moment, but the 7 cups work quite well. And you've got the one in the middle, which is like the penguin that's stuck in the middle. We've got the thermometer in it, and we've got the ones on the outside. So I wonder what's going to happen. So these are these are only very short snippets of video that I'll just run through with you, and hopefully you'll be able to hear them. So what's the temperature at the moment, and how do you know?
It's 36 on this one.
How do you know it's 36?
Because all of them equal 2, and the top one is 30. No, the one. So that one's 40, and then 2 under would be. No, 1 under would be 38, and then another one under would be 36 because it counts in 2s.
Okay, so we can see the kids, those who can count in groups of 2 or whatever it might like to be, but also they're beginning to see that idea of the marking represented a certain number. Now at a Year 3 level, which this is set at, that's a pretty new type of concept for them. So to give them the opportunity to see it, we wouldn't normally do, in maths, what does that look like? We give them a coloured diagram and ask them to colour up where 38 degrees is or something. It's got no relevance, whereas this has some relevance to it. This next one, they talk about, well, I'll let you figure out what they're talking about. What happened with your first measurement? What did you have on them? Was it the same?
40 and 40.
40 and 40. What do you think is going to happen to the middle one?
It's going to get hotter.
It's going to get hotter? Okay, so it's going to go up?
Yeah.
Okay, what do you think is going to happen to the outside one?
The outside one's going to get colder.
And it's going to go down?
Yeah.
Is that right? Okay, cool. So we just wait and see now. I like the way you started doing your graph. That's terrific. Okay, so again, this is talking about what they think is going to happen in the science for the size part of it. That middle one is actually going to draw heat from the outside ones, and it's actually going to go up. This is what they think. So what we're going to do is try and collect some data on that to see if that actually happens, and then analyse the data across the group with all the children talking about it to see whether or not their data backs up what their initial thoughts were. So the next one, this is about how they work out the difference between those numbers. And I get muddled up in the middle of this one, so I apologise for that. But difference between those temperatures.
So the first one was 2, and then that one was 7.
How do you work that out?
Because just counting down.
So can you give me an example of what that was? How do you count down?
Because one take away 7, and then 1 take away 8 is 7. So it should be it should be no, it's 2. 2.
No, he saw the first one was 2. We said how much is it from the second one to the third one. Sorry, but the difference is, what we're working out is, we want to know what the difference is between this one and this one, which is 2, but also we want to know the difference between this one and this one, which is how many?
That's 9.
9. And how did you get 9?
I know because count down from 40 to 31.
Cool. Okay, that's cool. Okay, so in this point, we can, if you were knowledgeable of the Australian curriculum, the mathematics, you can start assessing where kids are at. He was saying 1 take 7, 1 take 8. So he's got a bit of a mix up there. So that's something that I could follow through in a maths lesson with to really make sure that he had that full understanding of it. He's talking about counting down, but yet his answer is almost immediate. So the suggestion is actually a known fact for whatever reason that might be, and that's something else that I might like to investigate further along the line. But you can see in these 3 short videos, we're already getting some really good information and knowledge about their actual mathematics ability, but it's in the middle of a science lesson, which is great. Okay, so here's a couple more. This is more about graphing now. Explain to me your graph. Explain to me what you've got again.
We were doing how many pennies, and on this one was outside in 5 minutes, and that was outside in 10 minutes, and that's inside for 5 minutes, and it worked, and that was at the start of how they were, and it ended up to both of them for the same in each minute.
Okay, so the start, what was the difference between the start and the first 5 minutes? Because if I look at the graph, it looks pretty similar. How can I make it so it's really clear?
Well, it went down 2.
Oh, down 2. Could you graph the amount it goes down? Mm-hmm. What would that look like?
So you would write down 2, and
all right,
you go up from 40.
I love the way you've combined both graphs together. I think that's really clever. I wonder if you can do me a little graph up here about what the difference is each time. Okay, so side-by-side column graph doesn't actually come until much later, but because these children weren't restricted by me saying this is exactly how you have to graph it, they were quite happy to go on and do that sort of thing and to get it. Often in graphing, what we do is we give them a piece of grid paper and we say it needs to have a column there and an axis here and an axis there, and you need to put labels here and labels there and everything else. I won't show you this one because we'll run out of time, but the purpose of this one was there were no labels whatsoever. So I actually asked the young girl, how do I know what that is? Oh, I should have put a label on it. So she knew what the issue was, all right? Whereas if I just say, you have to do this, they don't tend not to remember it as well. So it's much better if you make sure that they have the opportunity to do it themselves. You'll notice that in this case, most of the paper is all blank because the blank gives us a lot of information about the misconceptions they have. And I'll show you a picture of one of those in a moment. Okay, so this next one is talking about the way the numbers appear on the graph and what they actually explain. Where is 10 degrees?
There.
Where exactly? Anywhere in this box?
In the middle.
In the middle of the box. Well, where would 9 be then?
In between the 10 and the 8.
Right, in between the 10 and the 8. So we've got to be a bit more exact than that. So where's your 0 going to be?
There.
Where's there? On that line at the bottom or in the box next to it?
In the line at the bottom.
So where's 2 going to be?
In the middle.
Where's 4 going to be?
In the middle.
But why can 0 be on the line and 2's going to be what? Here in the middle? Or is it there? Or is it there? Is it there? Is it where?
Along there.
Along here? Is that what you're saying?
Yes.
Well, that's a line. So does the 2 go on the line? Is that like the thermometer? Where's 30 go? Is it between the 20 and the 30? Or is it actually on the line that marks 30?
It's on the line that marks 30.
Right, so where's your 2 going to go? What do you think? What do you think?
This might take forever.
It's got to go above the 0, but exactly where would 2 be? So if I said it was 2 degrees, where would I colour up to? Right.
One box.
So, so the 2 has to go on the line. Is that what you're saying?
Yeah.
So where would 4 go?
You have to rub all of it out. There on the line.
Where would 6 go?
There on that line.
Right. And if that's true, where would 5 be?
Doesn't Matilda sit there?
Yeah, but she is here.
And I have to
Or here where there is no line.
Right, between the 4 and the
3. No, 6.
6. Okay, so do you want to change that?
Yes.
Okay, go for it. Okay, so there's a couple of interesting things there. One is that wait time that I'm terrible at, but you have to wait to make sure. There's also that it's somewhere around here. So having the thermometer there, because it was the context of the science experiment, which she'd actually read those degrees off quite readily, it gave her an example of what she could see. So she knew on the thermometer, it has to be the line, or if it's between the line, then the degrees are between those degrees. She could then relate that back to this. Okay? So I've got these aren't videos anymore, so you don't have to have any more videos. But this was a similar conversation I had with another young lady. Now this was about a different experiment. So at the end of that Penguin project, there's another experiment that talks about how do they keep warm, and it talks about insulating materials. So the kids get 2 cups, one with no material around it and one with material around it, and they measure the differences in temperature over a period of time. So this was the graph this young girl created. Now she had the same issue that the one we spoke to before had, the fact that the numbers were actually in between in the boxes, and when you colour in the box, that's 10. And so I asked her the same sorts of questions, and in the end, she then developed this. And she actually then drew in all the lines as well to show where 1 and etc. was. But if I said to her afterwards, well, where would 9 be? And she could easily point it out that it's between 8 and 10, etc. These are other representations which are really valuable for us to use. So at the end of any maths lesson, I have what I call an orchestration, or some people call it a share. But unfortunately, share becomes this thing about, I'm so egocentric, I'm going to tell you what you're going to do, and you're a captive audience, you have to listen. But half the kids don't. They're looking out the window and all the rest of it. So in an orchestration, we're trying to get all the kids involved in the discussion around it. So this is a good example I would use in this, where I would put that up and I'll put it up against one maybe like this. What's the difference between those 2 graphs? And the sorts of conversation you get is that the degrees here are equally spaced, whereas there they're not. So is that an issue? Is that a problem? Can you tell me about it? Can you discuss it? And we go on and have conversations around it. But also some really nice representations, because they weren't told to do a graph as such. Some of the representations that they've came up with is something like this, where it's gone from 36, it's gone to 36, but then it drops to 35. A 36 drops to 34. And then this person who's you're probably hard to see it there, but they've got the numbers and the graphs again the numbers in the boxes, but they've drawn little thermometers to show where it went up to, which I think is quite cute.